Why's that board shaking all of a sudden? I came back from Christmas break and my board wouldn't come on. I was getting a little nervous. All right. These are my x values. Now, guys, you might see y equals sine x or y equals sine theta. That's the same thing, okay? Sometimes you're going to see theta a lot more because you're dealing with angles, okay? But these are your input values, your output. If I asked you for y equals sine of 0, we should know that off the top of our head. What's sine of 0? Where's 0 located? If I'm looking, sine of 0 is located right here, isn't it? So what is my value of sine of 0? 0, thank you. So I'm going to put 0 here. What is sine of pi over 2?
That would be 90. 90.
It is 90, but what is the sine of 90 then? 1. Do y'all see how I'm getting that? What is sine of pi? Pi is at the coordinate negative 1, 0, so what is it? 0. Sine of 2 pi would be 1. Because 2 pi is back here. This is coordinate 1, 0. You see that? Are we good? Are you sure? So if I graph this, oh, we missed 3 pi over 2 right here. That's the point. What is sine of 3 pi over 2? Negative 1. We hit all our major points there.
So the answer says just your x coordinate.
Okay, no. What is sine, y'all? Is your what coordinate? Your y. Your cosine is your x.
Yeah.
It is. It is. It is 0. Thank you. It is 0. Can't read which part, but oh, gotcha.
It's big enough.
I just wrote it sloppy. Okay, that's sine of theta. The theta sine. All right, so let's graph those points. I got 0, 0. Now, I'm going to write pi over 2 Now, I'm going to show you how you would have done the other ones, because if we did every one of these, we would have every one of them on the x coordinate. But let's just say we did sine pi over 6. Y equals sine of pi over 6. What's the coordinate for pi over 6? Oh, Jesus, take the wheel. Come on. What is pi over 6? What's your coordinate pair? Okay, root 3 over 2, 1/2. Let's take a moment. What is your ordered pair for pi over 6? And what is your ordered pair for pi over 4? Very good. What is your ordered pair for pi over 3?
1/2 square root of 3 over 2.
Very good. What's your ordered pair for 0 and 2 pi? 1, 0. What is it for pi over 2? Remember, 0's here. 90. What's your ordered pair for pi? 3 pi over 2. Are we good now? Are you sure? Okay. See you. Now, so if I said y equals sine of pi over 6, that value would be what? 1/2, wouldn't it? So I would put pi over 6 and have a point right there. Okay? Next would be sine of pi over 4. What is the value sine of pi over 4? Square root of 2 over. So you say, Mr. Harris, how would you graph that? Okay, hold on. Square root of 2 divided by 2 is 0.7. You would estimate. Somewhere in there. If I did pi over 3, that would be square root of 3 over 2, wouldn't it? And that's 0.9. But do you see how all those little points are in between there? I'm not just to do that whole chart, but you see how that would work. Does that make sense? All right. Now, let's look at this. This is pi over 2, pi. I'm going up by halves, aren't I? This is 3 pi over 2. That's 4 pi over 2. Let's think about 5 pi over 2. 5 pi over 2. How many times does 2 go in 5? Twice. Let me write it down so you can see this. Let's say if we just kept going. If I have y equals sine of 5 pi over 2, 5 pi over 2, 2 goes in 5 2 times, well, how many left over? 1. So I'm back at what? 90 degrees, aren't I? So what's sine of 90? 1. So if I did 5 pi over 2, I'm back there. Okay, let's say I did y equals sine of 6 pi over 2, which would be what? 3 pi, wouldn't it? So I'm really at pi, aren't I? So I'm back at, I'm back at 0. I did y equals sine of 7 pi over 2. How many times does 2 go into 7? 3, and how many's left over? That means I went around the unit circle once. This is my third. I'm back at 3 pi over 2. Does that make sense? So that would be what? -1, so I'm down here. And then y equals sine of 8 pi over 2 is 4 pi, isn't it? So I'm back here. So what do you, that's kind of sloppy, but what do you notice happens to this graph? It does keep what? It keeps going. The whole purpose of that exercise is to show you that it keeps going. It is a continuous function. It never stops, okay? But if I asked you to graph the parent function, you would only graph from 0 to 2 pi. You got me? I'm just showing you that keeps going. Does that make sense? So let's look at what we notice about the sine graph, okay? Some characteristics. Domain. Now you might want to jot this down. I'm not going to have a spot for it, but you need to know this. Domain. What do you think the domain is?
0.
What is it? Out here in 0 to infinity. Here in all real numbers. What do y'all think?
No.
Remember, I tell you it keeps what?
Keeps going.
I want you to think about this. Can you go reverse on the unit circle? Could I go negative values? So what is it? All real numbers. That thing means that thing keeps going this way, and it keeps going this way, so it's all real numbers. Okay? What is the range for the parent function? -1 to 1. And guys, what you notice is it's bouncing up and down. That bouncing is called oscillating. So you need to know that vocabulary word, oscillating. This is oscillation. It's like a spring. You study springs, how it bounces up and down. That's why it's called oscillating. It's from -1 to 1. What would you put around here? Put around it. Brackets, parentheses. Brackets, yes, buddy.
I thought of another real life application when we were looking at that. They use that in electrical engineering.
Yes.
Because the electrical waves they get.
Anything with waves, that's right. Sonar rays, electrical waves. Alright. So, this is the parent function for sine right there. Domain, all real numbers, range, -1 to 1. X-intercepts. Where do you see it's crossing the x-axis at?
Pi.
Pi. Whole number pi. Pi. 2 pi. 3 pi. 4 pi. -pi. -2 pi. So the way I write this is n pi, because you can't list all of them. They go on to infinity. For which n is an element of z. What does z stand for in math? Remember from middle school? Integer. Z means integer. That means whole positive and negative numbers. So that's how you write it. X-intercept, n pi, for which n is an element of the integer family. That little e, that means element, a member. Okay?
So it would be NEZ.
No, you write n pi, and then put n is an element of z. That's how you write that. E, a little e, z. It's a crazy looking E, I know. It's a backwards E. But that's the element symbol in math. You learn some new symbols. It has symmetry that is odd. What does odd mean? Odd has symmetry about the y-axis or origin. What is, guys? We just learned this. What is odd? Symmetry about the what? Origin. Remember, odd origin. Odd origin.
Because it went the other way.
Mm-hmm. Even is symmetry about the y. Do we ever worry about symmetry about the x? No. Even is y. Origin. Odd is origin. Now, in behavior, we always talk about as x goes to infinity, what is happening to the y values. Or as x goes to negative infinity, what's happening to the y values. Well, guys, we don't have that because what's happening to the graph is it's bouncing from one part to another. So is it ever going to one similar place? So you put for in behavior does not exist. I don't make you write that notation right now. You can just does not exist because it's bouncing. It's bouncing. What I want you to notice about this, now we're going to talk about a little bit about this graph right here. You need to know this. Where does sine start? Does it start? It starts at the origin usually, don't it? Okay. Now, there's two characteristics that you're going to need to know. Words. Something called the amplitude and the period. Did y'all do this last year in altitude? You got introduced to it. Okay. Amplitude. What is amplitude in your own words? The height of the graph. You know, if you turn the amp up on your music, it gets louder, don't it? Amplitude is the height, how tall the graph is. Like here, the amplitude is 1. It's 1 because it goes up 1 unit and down 1 unit. Do you see that? Amplitude is the height. The period is the distance it takes to complete one cycle. And when I mean cycle, it starts here and ends back at the place. This is a cycle. You see it started here, ended back up here on the, because it keeps going. That is a cycle. The period would be 2 pi here because it took, that's how long the distance it took to complete one cycle of the graph. Because it's oscillating, it's repeating, it's cycling. So period is the distance. So what you need to know is that it starts at the origin, goes up, comes back to x-axis, down, back to x-axis. So do you see that pattern? Okay? Now, let's look at cosine. Okay, we're going to do the major points of cosine. What is cosine of 0? Your minds have warmed up, so you better start saying something. Cosine of 0. 1, thank you. Cosine of pi over 2. 0. Cosine of 3 pi, cosine of pi. Negative 1. Cosine of 3 pi over 2. Cosine of 3 pi over 2. 0. Cosine of 2 pi. 1. Remember, cosine is your x value. We're going to graph those points. So in this particular problem, in sine you start at the origin. Cosine, you start up at the what? Amplitude. Do you see that? Amplitude to the x-axis, down and back up. This thing will keep going. It will keep going. So, is it continuous? Yes or no? Continuous? Yes. What is your domain, guys? All our numbers, because this thing keeps going this way as well. Okay? What's your range? Negative 1 to 1 with what around it? Brackets. Very good. Does it have end behavior? No, it does not exist. Just like sine, because of the oscillations occurring, it's bouncing. What type of symmetry does this have? Even. It will be even, because if it keeps going, it's going to fold over the y-axis. So it is symmetry of even. Now, where's the x-intercepts occurring at? At the half marks, aren't there? So that's why you see pi over 2n. On the other one, it was pi n. Well, here will be pi over 2n because it's occurring at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, negative pi over 2, negative 3 pi over 2. Does that make sense? That is where it's crossing the x-axis at. You said, Mr. Chester, do I need to be aware of this information? Yes, you do, because it might be listed on your test. So you need to know the domain, the range, the x-intercept, symmetry, and end behavior. Remember, end behavior is the same for both of them. Does not exist because of the oscillations. The cosine has the even symmetry, sine has odd. X-intercept, domain, and range is the same on both of them, aren't they? But you've got to know the shape of the graph, the look of the graph. Because when we start graphing others besides the parent, I'm going to say, okay, does the sine start at the origin or at the amplitude? Sine starts at the what? Origin. Cosine starts up at the what? Amplitude, okay? Does that make sense? Are we good so far? Alright. So, we're good on the parent functions. Okay, let's look at the bottom. And I want to look at number 1 and 2 today. If we don't finish it, that's what the video is on. It's questions 1 and 2, okay? You don't have any homework on this tonight. You're just your homework was on that math workshop to refresh your mind by that evaluating Trig for your Trig Tuesday quiz, okay? If you came in late and missed the homework, ask your group. All right, now let's look at this. How would you find the amplitude and period if it wasn't just parent function? So we're going to get into other things. Let's say we had this right here. I'm going to make one up. Y equals 5 cosine 2x. What if we had to graph that? How would we find the period and amplitude? Amplitude is always the A value. The A value is in front of the cosine or sine, okay? And you take the absolute value of the A. What's the absolute value of 5? That's your amplitude. That means you would have 5 up here and what down here? Negative 5. Do you understand what I'm saying? That's your amplitude. So for this one, I would put amp equals 5. It's always, if that had been negative 5, my amplitude, absolute value of negative 5 is 5, okay? The negative would just be help you in reflecting the graph, okay? Now, so there's your note. A, absolute value A is the amplitude. Now look here, period deals with the B value that's in front of the variable, but you got to do something with that B value. You can't just put it down. The formula to find the period of the function is 2 pi divided by that value. That value B is the value in front of the variable, okay? Or in front of the, it could be in front of the variable or theta, x or theta. It's the number in front of that. So if I have 2 right here, my formula would be 2 pi over 2. What's 2 pi divided by 2? Pi. So my period for this particular one will be pi. Does that make sense? And what is the significance of that? What is the significance of the period? It's the what? Distance it takes to complete one what? Cycle. Okay? Let's look at another one. Let's say I had, I know I'm just writing, I'm just making up stuff right here. Y equals negative 3 sine 4 theta. What is, now I'm not asking you for certain things, like I'm going to ask you for what is the A value there? Negative 3. To find the amplitude, I would take the absolute value of negative 3. So what's the absolute value of negative 3? 3. So my amp is 3. What is my B value? My B value is 4. So to find my period, I say 2 pi divided by B. What's 2 pi divided by 4? Pi over 2. So my period for this particular one will be pi over 2. Does that make sense? You good, Derek? Are you sure? So that means the distance it will take to take one period will be pi over 2. So amplitude is the absolute value of the A value. To find the period is 2 pi divided by B, and B is the value in front of theta or in front of x. Okay? Now, we're going to start number 1. We want to graph 2 cycles of each function. Okay, number 1. First of all, I'm not asking for amplitude. I'm asking you to identify your A and B values. What is my A in this one, class? 1. What is in front of cosine? 1. What is the absolute value of 1? So I will put 1 next to amp. Do you see that? My period is 2 pi divided by B. What is my B value here? 2. So my period is pi. My period is pi. Amplitude is easy to graph on the y-axis. How high up are you going to go on the y on this one? 1 and down to what? Negative 1. You say, Mr. Church, what if my amplitude was 3? Then you would go 1, 2, 3. Okay, just don't put 3 up there. I got to say 1, 2, and then 3. Okay. This is the hardest part for students here. Is what do we put on the x-axis? Now I'm going to teach you how. I'm going to tell you, when I went to college, I didn't learn this in high school. This was so brand new to me when I went to college, and this was one of my hardest lessons. I could not figure out. Our teacher expected us to do that in our head. Look at the parent function and then draw it. I can't do that, so I had to figure out a way from Ms. Fester to learn this. Okay, you take your period. This is what you do every time. Take your period and divide it by 4. So if I took 1 pi and divide by 4, what is that? Pi over 4. You start your x with pi over 4. Every time you take your period and divide by 4. So, this will be pi over 4. Pi over 4 is like 1/4, isn't it? That means I'm going to start with 1/4 and I'm going to increase by 1/4. If I want to graph 2 cycles, I'm going to end up having 9 things on my x-axis. But do I count the origin as one of those 9? So yes, so this is 1. So how many am I going to write here? 8 on this. Do you understand? I'm going to show you why that in just a minute. So this is 1/4. What comes after 1/4 if I add in a 4th? 2/4, aren't it? Can I reduce 2/4? Yes. To what? Pi over 2. What comes after 2/4? 3/4. Can I reduce 3/4? No. What comes after 3/4? 4 pi over 4, don't it? Can I reduce 4 pi over 4? To what? Pi. Okay, that's 4 pi over 4. What comes after 4 pi over 4? 5 pi over 4. So, can I reduce 5 pi over 4? Don't change it to mix. No, I'm saying, can you simplify it? No, so I'm going to put 5 pi over 4. After 5 pi over 4 comes what? 6 pi over 4, which reduces to 3 pi over 2. After that is, can't reduce that. And then what? 8 pi over 4, which is 2 pi. Now, there's not enough room on here. If you don't ever try to bunch it up, I should have started this. Get you some graph paper and do it on this if you can't make it nice and neat, okay? And there's some up here when you leave if you want some. Now, let's see why this makes sense. It says graph 2 cycles. What's the period of this function? Pi. That means it takes that's the distance to complete one cycle, isn't it? So did we do it correctly if we grab 2 cycles? Because the first cycle is going to be from pi, and the next one will be from pi to 2 pi. That's 2 pi. You see why that makes sense? Okay, now, cosine to graph this. That's the hardest part. Do I start at the origin or at my amplitude? So I go here, put a dot here, dot here, dot here, back up. And let's put arrows on the end of it to let someone know that it is continuous, okay? It keeps going. But that is my graph for that cosine function. Now you say, Mr. Fisher, what if I forget where to put dots? Couldn't you put 2 times pi over 4? 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. Is my dot located in the right spot? Okay, pi over 2. 2 times pi over 2, 2 times pi over 2 is pi. Cosine of pi is -1, so is my dot in the right spot? So you can check yourself by inputting those values, yes.
When does it flip over the x-axis?
Okay. We won't get to when it stops, probably, what time will we get out? Okay, I got time to do another one. If I do another one, you don't have to watch video. This is what the video is. It flips over the x-axis when you have a negative out in front of it. And we're going to do that tomorrow, okay? But I got time to do one more. We got 5 minutes. If I do this, you don't have to watch it. Oh, I thought it was 9:07. So, tonight the video consists of this. You can review this and watch that, okay? And we're going to pick up with that tomorrow.